These are the notes on how to find what are called the trigonometric ratios, or trig ratios for short. Alright, so trigonometry is a branch of math that has to do with triangles. And it's actually two words kind of crammed together. It's triangle and geometry. And what we're going to look at first is how to do what are called these trig ratios. And there's 3 of them. And they're very useful for finding sides and angles of right triangles. But for now, we're just going to identify the 3 types of ratios. So the first type is what's called the sine ratio. It's spelled S-I-N-E. On a calculator, it's just shorted to S-I-N. But don't call it sin, it's pronounced sine. And what the sine is, it is the opposite side over the hypotenuse. The second one is called the cosine. And on the calculator, it's shortened to COS. But don't call it cos, it's cosine. And what that is the adjacent side over the hypotenuse. And the third type is called the tangents. On the calculator, it's TAN. And it is the opposite side over the adjacent side. Okay, so do you have to memorize these? That is a question. So do you have to memorize all that I just told you? And the answer is yes. So do you have to memorize this? And I'm going to say yes, you do have to memorize this. So how can we make it easy to memorize? And people have come up with different things, different ways to do it. Probably the most popular way is this thing called SOHCAHTOA. So you have sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and then tangent, opposite over adjacent. That's probably the most common way to do it. So when you're doing a test or whatever, the first thing I would do would be write that at the top of your page so you have it to look at, and that'll make it a little easier to remember this. It's SOHCAHTOA. Okay, another way is by this saying. You can do some old hippie came a hopping through our apartment. So there's two ways, there's probably more. So we have sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Those things you have to remember. So how do you use these, and what is it used for? So first let's talk about how do you make the ratios. Okay, here's an example. Here I have a right triangle, and we're trying to find the sine of A. So first thing I want to do is identify which angle we're talking about. So we have angles A, B, C. We're looking for the sine of A. So this is the angle that we're talking about. So that's our target angle. Then I want to identify which sides are which. So I learned from the previous lesson that the hypotenuse is the side across from the right angle. So it's right here. And the opposite side is the side across from the target angle. So it's here. And then the adjacent side is whatever's left. So we're doing sine, and I know from my sayings that sine is so, or it's some old hippie, however you want to think about it. Either way, it's opposite over hypotenuse. So I'm going to look and see where's my opposite. So the opposite is equal to, for this one, it's 10. So the sine of A equals 10. And then the hypotenuse is 26. So it's 10 over 26. And then, of course, I can simplify that, because 2 goes into 10 5 times, and 2 goes into 26 13 times. So the sine of A is equal to 5 over 13. Okay, let's look at another example. So this time I have a right triangle with 3, 4, and 5 for the side lengths. We're looking for the cosine of C. Let's identify the angle. Here's angle C. That's our target angle. Then let's identify the sides. The 5 is going to be the hypotenuse. Hypotenuse is always the biggest side. That's another way you can find it if you have all three sides. Side opposite C is the 4, or side BA, and that means that 3 has to be the adjacent side. Okay, so cosine is the ka. Cosine is the ka part of SOHCAHTOA. Or you can think of some old hippie came a hoppin'. Either way, it's the adjacent over the hypotenuse. So cosine of C is equal to the adjacent side over the hypotenuse side. And that's going to equal the 3 over 5. And that we cannot simplify, so we're done. Okay, one more example. This time we have a right triangle with sides of 12, 35, and 37, and we're looking for the tangent. So I know from my sayings that tangent could be the TOA, opposite over adjacent, or it's through our apartment of our some old hippie came a hopping through our apartment. Either way, whatever you need to do, remember it, you need to remember it. So opposite over adjacent for tangent of Z. Okay, so first we have to identify which side is opposite, which side is adjacent. We know the 37 is the hypotenuse, it's the biggest side. It's also the side opposite the right angle. Okay, and we're looking at angle Z, which is right here. The side opposite the Z is a 35. And the side adjacent to the Z is a 12. So tangent of Z is equal to side 35 over 12. And that we cannot simplify.